Simplifying and operations with radicals. For these next examples, we're just going to simplify radical equations. So what we have to do when we're simplifying is we need to tree out our square roots. So when I do that, I'm going to be looking for perfect squares. So when I tree this out, I could tree it out as 16 times 10 is 160. So the square root of 16 times the square root of 10 is 100 square root of 160. Now the square root of 16 is 4. And the square root of 10 we can break down more into 5 and 2. But from there we can't break it down anymore. So my final answer is going to be 4 times the square root of 10. Since I can't break this down anymore, it goes back up to this one. And that would be your final answer. Next one, square root of 72. So I'm going to break that down looking for my perfect squares. So I could say 4 goes into 72, and 4 times 18 is 72. So the square root of 4 times the square root of 18 is 72. But 4, square root of 4 is just 2. And now I break down my 18 into the square root of 9 times the square root of 2. So the square root of 9 is just 3. So I have 2 times 3 times the square root of 2. So that leaves my final answer to be 2 times 3, which is 6, times the square root of 2. 6 square root of 2. Final answer. Now we're going to simplify radicals that have variables with them. A little bit harder usually when we're doing it this way, but we would just start by splitting apart the number part, square root of 54, and the variable part, n to the 7th. Okay, so at this point, what we're going to do is tree out our square root of 54, which would make it 9 times 6. Okay, and those are both under the square root. So the square root of 9 is 3, and 6 would break down to the square root of 3 and the square root of 2, which doesn't break down anymore. So that's going to go back to what I had before. So the number part is going to be 3 square root of 6. Now I need to figure out what I need to do with my square root of my variable. So I have the square root of n to the 7th. Okay, so on this one, I'm going to break it down the same way, and I'm going to be looking for groups of 2 n's, because it's a square root. So I have n squared, and then I have n to the 5th. That's how many I have left. That's under the square root. So this part is going to go to n. And then here I'm going to have n squared and n to the 3rd. So this n right here, n squared, square root of n squared, is going to go to n. And then finally, this last part, I have n squared times n. So again, this is going to go to n, because these are all n square root of n squared, square root of n squared, square root of n squared. There's 3 of them, so that's going to tell me that I have n cubed, because there's 3 of them, and they're multiplied together, and then I have the n square root of n left. So that would be my variable part. Now I put those two together, and I get a final answer of 3 n cubed, and that's outside the square root, and inside the square root I have 6n, and that would be your final answer. The next problem, we have negative m times the square root of 80m to the 9th. Okay, so again, I'm going to have my negative m on the outside and my square root of 80, and then times the square root of m to the 9th. Okay, so I'm going to start with my 80. It's going to break down into 16 and 5. So the square root of 16 times the square root of 5 is the square root of 80. But the square root of 16 is just 4. So I have 4 times the square root of 5. So what I have now is negative m times 4 times the square root of 5 times the square root of m to the 9th. So now I have to deal with the square root of m to the 9th. So that's going to tree out and give me the square root of m squared times the square root of m to the 7th. Keep going. And I'm going to have the square root of m squared, square root of m to the 5th. So last step is to tree out this one. Square root of m squared, square root of m to the 3rd. So I'm going to rewrite this down here. I have negative m times 4 times the square root of 5 times, this is m, here's an m, and here's an m, and then this is square root of m cubed, which can be broken down a little bit more, just didn't have room. So that would make it m squared and m. So that again goes to m. So my final answer, when I put it all together, I have negative 4 times my m times m times m times m times m. So that would be m to the 5th power. And then under my square root, I still have the square root of 5, and I have an m still under the square root. So your final answer, negative 4m to the 5th times the square root of 5m. For these next two examples, we're going to multiply. So you multiply the things on the outside and multiply the things on the inside, and then you simplify. So my first step, 3 times 2 is 6. And then I'm going to multiply the inside. 7 times 14 is 98. N times n squared is n cubed. So what I'm going to do now is simplify my square root. So I'm going to simplify the 98, and it's going to go to the square root of 2 times the square root of 49. But we know the square root of 49 is 7. So I have the square root of 2 times the square root of 7 times the 6 times my square root of n cubed. So now I have to deal with the n cubed. N squared times n, all under the square root. N squared is just going to go to n. So I have n, square root of n. Okay, so now I put everything together. 6 times 7 times n is all outside the square root. So I have 6 times 7, which is 42, times my n, and what's left under the square root? The square root of 2 and the square root of n. So that is your final answer. And the next one, we have to multiply the outside. 7 times 3 is 21. And multiply the inside. Square root 5 times 20 is 100. X times x to the 5th is x to the 6th. So I'm just going to go ahead and split up those right now. So now the square root of 100 is just 10. So I have 21 times 10 times the square root of x to the 6th. So I'm going to figure this one out. So that would be x squared and x to the 4th, and then x squared and x squared. So these are all going to go to just x. So my final answer is going to be 21 times 10 times x times x times x, which we simplify to 210x cubed. Final answer. Dividing radicals is very similar to multiplying them. You can either split them up, or you can do them separately, or you can divide and then do your square root. So what I'm going to do on this one is I'm going to write it as square root of 64 divided by the square root of 49. And the reason I'm going to do that is because I know the square root of 64 is 8, and I know the square root of 49 is 7. So I have 8 over 7, and that's your final answer. The next one, we have the square root of 8x cubed over 50x. Now this one, I'm going to deal with the x's here by simplifying that. So under the square root, I'm going to have 8 over 50, I'll deal with the number later, times the x cubed and the x. So, since there are 3 x's on top and 1 on the bottom, it's going to go to just x squared over 1. So now if I split this part up, I have the square root of 8 over 50 times the square root of x squared. Well, the square root of x squared is just x. So I have x times the square root of 8 over 50. So now I want to simplify 8 over 50. So that's going to go to the square root of 2 times the square root of 4 over the square root of 2 times the square root of 25. Square root of 4 is 2. Square root of 25 is 5. So if I were to rewrite this, what I have is x times the square root of 2 times 2 over the square root of 2 times 5. Square root of 2 divided by the square root of 2 is going to cancel out. So your final answer is going to be 2 times x over 5. You can say that because this is like saying x over 1. So x times 2 is 2x. 1 times 5 is 5. So there's your final answer. And the last set of problems we're going to do what's called rationalizing the denominator. So if we have the square root of 3 over the square root of 7. If we want to rationalize this denominator, we have to multiply by the square root of whatever your denominator is. So it's the square root of 7. So I take 3 times 7 and put it under the square root over square root of 7 times the square root of 7 is the square root of 49. Well, the square root of 49 is just 7. And then the square root of 21 can't simplify anymore, so it's just going to be the square root of 21 over 7. And that would be your final answer. Now the next one, we have the square root of 7 over the square root of 8n. So we're going to rationalize the denominator by multiplying by the square root of 8n, because that is in my denominator, and do it to both the numerator and the denominator. So what I would get would be the square root of 7 times 8, which is 56, times the n, over square root of 8 times 8, which is 64, n times n, which is n squared. Okay, so now when I simplify this, I have the square root of 4 times the square root of 14 times the square root of n. And then in the denominator, the square root of 64 times the square root of n squared. Now when I simplify this, that goes to square root of 64 is 8, square root of n squared is n, so I have 8n on the bottom. And in the numerator, square root of 4 is 2, and then the square root of 14 is going to stay the square root of 14, square root of n is going to stay the square root of n. So in the numerator I have 2 times the square root of 14n. And now I just simplify right here. 2 divided by 8 would be 1/4, so my final answer is going to be 1 square root of 14n, this is an n, divided by 4n, and that would be your final answer. So those are your notes over simplifying and operations with radicals. Go through some practice problems, make sure you can do the multiplication, the division, and the rationalizing, and then you should be ready for your quiz.